Go ahead. Yes,
When's our test?
I put it for Thursday, so that would give us time if we needed to like finish it later, we can. Of course you're not. Okay, all right. So today we're talking about counting. What that means is counting the possible ways you can organize things or choose things. So the first ones are, the first thing we have is the fundamental principle of counting. It just means if we have multiple ways to do certain things and we're doing all of them, to figure out the total possible, we multiply them together. So an easy way to look at that, an ice cream shop offers 1, 2, or 3 scoops of ice cream and has 8 different flavors, and they serve it in a cup, wafer cone, or a chocolate cone. We want to determine the total number of possible ways we can order the ice cream. So we've got the number of scoops, and then we have, what else can we choose? Flavor. And then we can also choose how it's served, cup, cone, or whatever. How many scoops? How many options do we have on scoops? 3. How many options do I have for the flavor? How many options do I have for the way they're going to serve it? So all we do is 3 times 8 times 3. 72. James needs a 4-digit password for his computer. The password can contain any number, but no repeating. How many possible passwords are there? So we need to think about the first digit, the second digit, the third digit, and the 4th digit. How many options does he have for the first digit? 0 through 9. So how many is that? 10. Now, he chose a number for his first digit, and it said we can't repeat. So how many numbers can he choose from for the second digit? 9. Okay, so now he's got the first digit, the second digit. How many does he have to choose from for the third digit? 8. Because it said they can't repeat. And then the last digit, 7. What if they had said they could repeat? 10 times 10 times 10 times 10. But because it said no repeating, we have to change it each time. So that total would be, okay, 5,040 ways. Now, the word permutation is another word for ordering, how we could order those passwords, how we could rearrange those items on the menu. When we count the number of permutations, we are counting the number of different ways that a group of items can be ordered. Now, so the official way of doing that is when we're choosing numbers of items is n times n minus 1 times n minus 2 times, isn't that what we did on the when we were doing the digits?
Yes.
10 minus 1 is 9, 10 minus 2 is 8, ... So let's say I had, and I'm going to do one example here. We have 6 books to go on a shelf. How could I arrange them? Well, to figure out what book's going to go first, how many do I have to choose from? The second book, I've already placed 1 book. I have 5, 4, 3. Now this comes up so often. There's actually a notation for that when you do 6 times 5 times 4 times 3 times 2 times 1. If this is also known as 6 with an exclamation, that's called a factorial. Now I find it just as easy to type in my calculator 6 times 5 times 4 times 3. But if it had been like 100 things, 100 times 99 times 98, wouldn't that take forever? So I want to show you the factorial button. It's an exclamation mark and it's right on the decimal spot there. So so when I go back to my calculator, if I do 6 and then press the alpha and then that decimal, it pulls up the exclamation. What it does is it does 6 times 5 times 4 times 3 times 2 times 1. And it says that's 720, whoops, I can't write, 720 ways. Now it's just as easy when it's small numbers to just do the 6 times 5 times 4. But that factorial button will do it for you. But we don't always need to go all the way down to 1, did we? On this one, it was 10 times 9 times 8 times 7. Yeah. So be really careful with that. Now here we've got 5 runners running a race. One of them will finish first, another will finish second, and so on. In how many different orders can they finish? So to become in first, how many runners have that option to be first? Well, out of 5, we got 5 runners. Okay. How many could be second? 4. Then third. Then 4th place. And then 5th place. Or how else could I do this? 5 with a little exclamation point, 5 factorial. Either way is fine. I find it just as easy to do 5 times 4 times 3 times 2. Calculator, did anybody do it?
Yes, 120.
120 ways. 10 runners run a race. The first place finisher gets a gold medal, second place gets silver, and third place gets a bronze medal. In how many different ways can the medals be awarded? So we're not talking about ranking all 10 of them, just first, second, and third. So first place, second place, and then third place. How many runners do we have that could have gotten first place? 10. And then second place, and then third place, 8. So 10 times 9 times 8, 720 ways. Now, what we just did in that last example, where we had 3 runners were chosen from a group of 10, and we had to order them first, second, and third. This is called a permutation of so many items chosen from a number of items. So a permutation of items, the main notation you're going to see in textbooks is NPR. Let me write that again. NPR. This means we have N items and we're picking so many of them. So in ours, that would have been, we had 10 runners. And we were picking how many for placing? 3. Picked 3. So if I'm using that notation for the last problem, it was 10, pick 3. Now there is a formula that we can use, even though 10 picking 3, you just did 10 times 9 times 8, and you were done. The formula I wanted to show you has n factorial, that means n times n minus 1 times n minus 2, all the way down, divided by n minus r factorial. And I just wanted to prove that that formula gives us the same thing we did if we just think logically. So 10 pick 3. The formula says I'm going to do 10 factorial over 10 minus 3 factorial. Factorial means I'm going to take 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. In the denominator, I've got 10 minus 3 factorial. What's 10 minus 3? So that would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Some things kind of cancel out. What cancels out? 7, 6, all the way down. So I'm just left with 10 times 9 times 8. For this one, the formula is more work than if you just think logically. Now, there is also a way to do this in the calculator, but again, I think the formula, even using the calculator, is more trouble than it's worth. I'll show you how to do it in the calculator. In my calculator, you would go to the toolbox, and then the first option you're going to choose is going to be the probability option. Isn't that weird? Probability for a probability section. Then we're going to choose a weird one. It says combinatorics. That means combinations. You know how many different ways you can do something. And for a permutation, we would select the option that says permute. Whoops, I cannot write permute. I wrote it with a W somehow. Permute. And it says N, comma, K. So for the example we just did, I would type in permute 10, comma, 3. I've got 10 items and I'm picking 3. Let me just show, we already did this one by hand. It's not hard to do 10 times 9 times 8. Let me just have up what that was.
Would you ever recommend this way to do it?
I would only recommend it if it was like 100 items and you were picking 80 or something. Like, oh, that would be too much by hand. But if it's big numbers, maybe you would go here. So I'm going to press the toolbox. Now I was already back there, so let me back all the way out. Toolbox. So up here was like when we were doing square roots, absolute value, logarithms. If we scroll down, there's one called probability. Probability is where we're going to go for a chapter called probability. And then the very first option is combinatorics. It's a horrible word. It just means combinations. And what we have is a permutation. So there's 2 options. It says combination, permutation. Oh, there's a factorial if we wanted it. I want that permutation. 10. And how many were we picking? 3. It does the same thing. I find it, if it's small numbers, easier just to do 10 times 9 times 8. And I'll talk through that as we go through the problems. So this one, 5 lifeguards. And I want to show this notation also because even though my calculator does a different notation, this is the one the textbook uses. Every textbook I've ever seen, the TI calculators, everything. 5 lifeguards are available for duty one Saturday afternoon. There are 3 lifeguard stations. In how many ways can the 3 lifeguards be chosen and ordered among the stations? In other words, somebody's going to get assigned to be in the first station, second station, third station. So we got 3 stations, the first one, the second one, and the third one. I tend to like to do these by hand. How many lifeguards could I pick to put at the first station?
3.
How many do I have? 5. And then for the second station, 4 now, and then 3. I tend to find it just as easy to do it by hand, but you could have also done this one. This is 5, pick 3, or in my calculator, that would be permute 5, 3. Whichever way you do it, I'll do it in the calculator. Permute 5, comma 3. I got 60.
I have a question.
Yes.
Doesn't it just ask for 3 lifeguards though, instead of all 5?
It says, how many can 3 be chosen out of those 5 and ordered?
Okay.
So it's the chosen part and ordered that makes a difference. Now the and ordered makes it a little different because we're assigning that each lifeguard station is like the first one in the row, second one in the row. We're assigning them to a location. Is that okay? In some cases, yes. In some cases, we want to just decide which lifeguards are working that day. And we're not assigning them to a location. So if we're choosing a set and we don't care about the ordering, we just care who gets picked. This is called a combination. Combination, I don't care about order. Order doesn't matter. Order doesn't matter. Now, I'll write the formula, but I'll be honest, I will not ever decide to use this formula. I would much rather use the calculator because this formula is a little more complicated. Not only am I picking those 3 lifeguards, but then I have to say, well, I've got Bob, Joe, and Susan. It could go Bob, Joe, and Susan, or Joe, Bob, Susan, or Susan, Bob, Joe. There's so many different ways they could line up. So this one comes out to be a lot bigger. Now the notation in choose R, the formula would be n factorial, but then they put a whole bunch of other stuff in the denominator. It's possible to do it by hand, but I don't, it's not my favorite. So on this one, we would also go to the toolbox. We would also go to probability and then the weird combinatorics, horrible name. But this time, instead of permute, we would choose the one that says combinations. And the notation this calculator uses is a parentheses with 2 numbers. It'd be the total over how many you're choosing. So as we write these, I'll show the notation that the textbook would use and the calculator uses. So we'll just talk about how they both work. At a certain event, 30 people attend, and 5 will be chosen at random to receive prizes. All prizes are the same, so the order doesn't matter. So how many different groups of 5 can be chosen? Wouldn't this take forever to plan out if you had 30 people? So this is definitely a calculator one. We've got 30 and we're choosing 5. In the calculator, this is going to be 30 over 5. So I'm going to go to the toolbox. If I wasn't in there already, I would choose probability, combinatorics, and the very first option says combination N over K. So I'm going to put the 30 over the 5. Now think about this. This is doing 30 times 29 times 28. It's getting big numbers. 30 choose 5. 142,506 ways to choose 5 people at random from a total of 30. Those would be big calculations by hand. The next examples, we first have to decide, is it a permutation? Are we picky about order? That's the way I remember it. Permutation is picky. Order matters. Or is it a combination? We're just choosing. So permutation is picky about order. And combination is just choosing. Just choosing. So in each of the problems, we're going to decide, is it picky about order? Or are we just choosing things? A business owner has a choice of 5 locations to open a new business. The business owner decided to rank each location. Is an order important on this problem? Okay, so this is P. How many different ways can the 5 locations be ranked? Well, they could be ranked first, second, third, fourth, or fifth. How many locations could we choose from for first place? 5. Second, 4, 3, 2, 1. On the permutations, I find it easier just to do it by hand. The formula calculator's not, I mean, just putting it 5 times 4 times 3 times 2 times 1 is not too hard. What was that? 120 ways. Now, what if he only wants to rank the top 3? That would be 5 pick 3, or permute, if you're using my calculator, 5, 3. Or couldn't you just do 5 times 4 times 3, the top 3? I tend to find this is just as easy just to do 5 times 4 times 3. And how many ways can we place the top 3? 60? Done. Drama club has 7 girls and 5 boys. A committee of 3 girls and 2 boys needs to be chosen. How many different possibilities are out there? So first off, we need to think of how we can choose the girls. The number of ways. First off, wait, does the order matter?
No.
If you're choosing 3 girls for a committee, does it matter which one gets picked first or second or third? Okay, so this is a combination. Number of ways to choose the girls. And then we're going to figure out the number of ways to choose the boys. So how many girls are there total in the club? 7. And I'm choosing how many? 3. So the official notation is 7, choose 3. My calculator does this parentheses, 7 over 3. And I do these with the calculator. Do not like to do these by hand. 7 over 3, 35. Okay. What about the number of ways to choose the boys? Well, how many boys are in the club?
5.
And we're choosing how many for the committee? 2. So in my calculator, that's 5 over 2.
It's 10.
Now, to get the total committee, I've got to take the number of possibilities for girls times the number of possibilities for boys. How many different ways were we able to select the girls? 35. And the number of ways to pick the boys? 10. So our total possibilities to set up this committee, 350. Total possible. That's a lot. All right. 14 art projects are subjects submitted to an art show. How many different ways can the judges award first and second place? Is this a permutation or a combination? Permutation means order matters. So this is first and second place. That means the order matters. I tend to not really use the formula for these because how many options do we have for first place and second place? Do I really need the formula? 14 times 13, 182 ways. Permutations are a lot easier than combinations. Okay. A newspaper has 8 movie reviews. They only want to publish 3 reviews this week. How many different ways can the 3 reviews be selected? Does the order of the reviews matter? Is there saying one's going to get to be on the first page of the newspaper, second page, third page? So if order doesn't matter, it's a C. These I do use the calculator on. How many possibles? 8, and we're choosing 3. In my calculator, that's 8 over 3. What'd you get? I did too. 56 ways. Done. 3 news stories are used throughout a broadcast. The one to open, the one in the middle, and the one to close. If there are 8 stories to choose from, how many ways can the broadcast be set up? Does the order matter this time? Yes. So the order matters. This is a permutation. We've got the one that's going to open, the one in the middle, and the one to close. How many stories do I have to choose from to pick the one that's going to open? What about the one for the middle? One to close? 6. 336. For permutations, I really it's a lot easier just to do it. Now, if it was 100 or 200 of them, maybe I wouldn't, but anyway. A seamstress must choose 2 colors for a dress. She has 5 to choose from. Find the number of combinations possible. Is it saying that one color is going to be top and bottom? No. So if it doesn't say anything about an order, it's a C. It's a combination. Oh, it actually said the word combination. That might have been a clue too. How many colors is she picking from? Well, she's choosing 2 from 5. So 5, choose 2. 10 ways. Now, this last one is the more complicated one. A box of light bulbs contains 8 good light bulbs and 2 burnt out bulbs. 4 bulbs are going to be selected at random. What is the probability that all 4 are good? So if we're trying to find the probability that all 4 are good, what we have to do is we have to figure out the number of ways to choose 4 good bulbs. Bulbs out of the total possible ways to choose 4 bulbs. So the denominator is always our total possible sample space. So all the different ways I could choose 4 bulbs. And that includes them being good, bad, whatever. So let's think about that one first. The total possible ways to choose 4 bulbs. How many light bulbs are in the box? There's 10 total light bulbs. Wait, does the order in which I pull the light bulbs out matter? Okay, so this is a C. 10, choose. How many am I choosing? 4. So the total possible ways, that's going to be 10, choose 4. So somebody do that for me. 10 choose 4.
210.
210. So this denominator is going to be 210. Now let's look at the number of ways to choose 4 good bulbs. So number of ways to choose 4 good bulbs. How many good bulbs are there? And we're choosing how many? Ah, so the numerator is going to be 8, choose 4. Out of those 8 good ones, we could pick these two, have 4, I don't know. There's a lot of different ways, 70 of them. So the probability that all 4 are good. How many ways could we choose 4 good bulbs?
7.
Out of all the possible ways to choose bulbs.
210.
So 70 out of 210.
1/3.
1/3. So this last one kind of brought it all together where we'd use these combinations and permutations to figure out all the different ways we could arrange things to be used in a probability. That is it. Then